Well, hi there, boys and girls. I'd like to go ahead and apologize if I have some coughs because I've got a little tickle in my throat, and so I apologize if that gets annoying. But see, there I go. Really, already? Seriously. Okay. Anyway, we're going to talk today about it's a new unit. We're going to be doing complex numbers and rational numbers and rational expressions and inequalities in this unit, and we're doing something that you should have seen in Algebra 2, which is the number I. And then, of course, I've got this later on. This is the square root of -1. And we're going to be talking about complex numbers today. And I'm going to show you some slides. And we'll talk about operations with complex numbers. Tomorrow in class, you'll have to add, subtract, multiply, and divide them together. Okay, so let's go on and go forward. Oh, by the way, I forgot. I got to give a shout out here to Brandon. So let's see here. Here's Brandon's shout out. That is so cute. That's just so cute. You're lucky, Brandon. Anyway, all right. So there's Brandon's shout out, and it's not from Mr. G. So better say yes. Anyway, here we go. All right. So we've got the imaginary unit I. It's defined as the square root of -1. If you square both sides here, you get that I squared equals -1. I'm going to go a little further with this as well. So we've got those two. The third one would be I cubed, and that would be I squared times I, which would be negative. I squared is -1, negative I. And then I to the fourth could be thought of as like I squared times I squared, which is -1 times -1, which is 1. And they go in a pattern after that. I to the fifth is the same thing as I. And I to the sixth is I squared. And I to the seventh is I cubed, and I to the eighth is back to 1. So your answers to I to any power, this is a common SAT kind of question too. I to any power, you need to see this pattern. They go in multiples of 4. So let's just write this down here. I to the first, we're just going to call that I. I squared, we're going to say that's -1. I cubed is -I, and I to the fourth, we're going to call that 1. So your answers to I to any power go in that order right there. So for example, if I had I to the 53rd power, this is the same thing as I to the 52nd times I to the first. Now why do you think I would pick a 52nd? Well, 52nd or 52, this is a multiple of 4. And I to any multiple of 4 is going to be 1. So this is the same thing as I to the 603rd. I would turn this into I to the 600 times I cubed. Why did I pick 600? Because that's a multiple of 4. So that's 1 times I cubed, which is just I cubed, which we call that -I. So these are your only 4 answers to I to any power because of a pattern. Okay, let's see. We're going to go over some complex numbers. By the way, every number is complex. If you complex numbers are of the form a plus bi, you probably remember this from Algebra 2. If there's no I in your number, we're going to call that a real number. If there's no a in your number and it's just got an I in it, we're going to call that an imaginary number. But if they have both, this is called a complex number. The real part is the part not connected to the I. The imaginary part is the one that's connected to the I. So here are 2 more examples with that. Okay, you are going to do some simplification first. So to express this as a multiple of I could call this the square root of -1 times the square root of 16. And this would simplify into 4I. If I squared 7I, I would get 49I squared, which is, do you remember what I squared is? I squared is -1, so this will be -49. All right, let's get to some operations. Adding and subtracting complex numbers is relatively easy. What we're going to do is we're going to add the real parts together or subtract the real parts together, depending on if we're adding and subtracting, and then we add or subtract the imaginary parts. So to do this problem right here, I would do 7 minus 9. I would combine just the real parts, and of course that's -2. Then I will combine my imaginary parts. 4i minus negative 5i is a positive 9i. And that is my answer. This is called standard form, a plus bi form. Let's do another example here. We'll take the real parts and add those together. So 8 plus 17 is 25. And then 3i plus negative 7i is minus 4i. So that's adding and subtracting. Very, very simple. Just collect like terms, basically. Add or subtract the real parts, then add or subtract the imaginary parts. And then put this in standard form. This is a plus bi form. Okay. To multiply, I went ahead and had an example here out of a book. And you need to either FOIL or box them. You're going to multiply the first times the first, and the outer times the outer, and the inner times the inner, and the last times the last. And there will be some simplification, and that comes in whenever you have an I squared. So notice that when we FOIL this, the very last term, negative 3i times negative 5i, is 15i squared. And look at that substitution. Anytime you have I squared, it turns into negative 1. And so this multiplies out. You collect your real terms, you collect your imaginary terms, and you put it in what we call standard form. So let's do an example of that. I'm going to FOIL this out. 3 times 6, 18. 3 times negative 2i is negative 6i. Negative 5i times 6 is negative 30i. And then negative 5i times negative 2i is positive 10i squared. So what I'm going to do next is I'm going to call that I squared a negative 1. So this is 18 minus 36i. Of course, negative 6i and negative 30i is negative 36i. And then this I squared becomes negative 1. So that positive 10 becomes a negative 10. And then I can combine the 18 and the negative 10 to call it 8 minus 36i. And there's my standard form answer. Okay. The hardest thing about complex numbers is dividing them. And we have used this word conjugate before. Conjugate means change the sign in the middle. So the conjugate of a plus bi is a minus bi. And the conjugate of a minus bi is a plus bi. And if you multiply these out, this difference of squares, you see it works out to be a real number. And what this is going to do for us is going to get any of the i's out of the denominator. Alright, so this is an example. If you don't, I'm going to show you an example past this, but if you were to divide this 7 plus 4i by 2 minus 5i, notice what we do. We're going to multiply by the conjugate, the top and bottom by the conjugate. We've done this before. When you do that, you FOIL the top and FOIL the bottom. In the bottom, you get a plus a squared plus b squared. And you see that there's no I in the denominator. And then break it apart into its fractions, a real part and imaginary part. So let's see this at work. Divide and express the result in standard form. So what we're going to do is multiply the top and bottom by the conjugate, which is 5 plus 9i over 5 plus 9i. Now let's FOIL. 7 times 5, 35. 7 times 9i, 63i. 6i times 5, that's 30i, and 6i times 9i is plus 54i squared. I'll fix that in a minute, the I squared part. Now on the bottom, if you FOIL this, that's fine, but I want you to realize we're going to get 5 squared plus 9 squared. And here's why. 5 times 5 is 25. 5 times 9i is 45i. And then negative 9i times 5 is negative 45i. You see how pretty that is? Those cancel each other. And then I'm going to get minus 81i squared. But what does this I squared do? It becomes a negative 1. And so you're going to see that those cancel. The I squared becomes negative 1, and we really just got 5 squared plus 9 squared. So you should probably take advantage of that little shortcut. Let's simplify this. So 54i squared becomes negative 54, so I'll have 35 plus 93i minus 54, and on the bottom I'm going to have 25 plus 81. That I squared became a negative 1. Okay, so 35 minus 54, what is that? That's a negative 19 plus 93i over 25 plus 81. That's 106, right? Okay. Now we're going to separate this into its real parts and its imaginary parts. So negative 19 over 106 plus 93 over 106i. So that's it. That's adding, subtracting, multiplying, dividing, and Brandon, you got your shout out. All right, guys, I will see you then tomorrow.